Today's video is sponsored by Native Sons Goods, makers of premium quality guitar, bag, and camera straps, handmade in Albuquerque, New Mexico. Check out their website to order your own custom creation and play in style. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hey everybody, how's it going? Brad the Guitarologist here. In this video, we're going to take a look at the pile. I'm sure you guys are familiar with the pile if you've been watching my channel for any length of time. Basically, I've got all the stuff that's coming up over on this side, and I've got the stuff that's next on this side, and what is next is this guy. This is a late 1960s, about a 1967, I'm guessing, Gibson. Which one is this? The GA15RVT. Let's pull it out of there, see what's wrong with it, and see what we need to do to fix it. Alright, so like I said, this is one of the later Gibson amplifiers. This is right toward the end of Gibson making tube amplifiers in the late 1960s. Like I said, around 1967 probably for this thing. It is a GA15RVT. The RVT stands for reverb and tremolo, and you can see here this has a little bit of a different layout than some of the other Gibson amplifiers from the 1960s. Here they were kind of sort of copying the the FENDER whole front facing thing, whereas a little bit earlier on they had an upward facing chassis. 3 inputs right here, and I don't think they're any different from one another. We have a loudness control, treble, bass, reverb, and tremolo with depth and frequency. We have a power switch with 2 ons for polarity, and we have a little light there as an indicator. These have pretty good handles on them. I've never seen one of these, I don't think, at least with a broken handle. There might have been one maybe I've ever seen with a broken handle. So those held up really well at least. The coverings on these also tend to hold up really well. I've never seen one where the covering was in really bad shape. I think they sort of take a beating. The cabinets are not made as well as the earlier Gibson cabinets. These are usually made of composite materials on some of the cabinet portions. Like the baffle is made of chipboard material, and also this little back door right here, this comes off and it's made of a chipboard material, and I think the rest of it is actually plywood. Yeah, see, you can see there the rest of it's plywood. These have a hard-wired foot switch to control the reverb and tremolo. This one does not have the original speaker. This is a realistic speaker from Radio Shack. You can see the speaker code there. I'm not sure who the maker is. 1206 would be the maker. I'm not sure if that's realistic or not. Well, no, maybe that's not the right code. Maybe that's that code. It's hard to read. Anyway, we know it's not original. And this one's also named the Explorer. Gibson had an amplifier called the Explorer earlier on as well in the Tweed era, which was the GA18, I believe, during the Tweed era. This is what makes Gibson somewhat confusing, because it's very hard. If you go to and look at Fenders, Fender was consistent throughout, pretty much. They had, if you got a Fender Tweed Deluxe, it was called a Deluxe, and it was a Deluxe, from the time it was from the Tweed era through the brown face and the black face, silver face, they called them Deluxe. Whereas Gibsons, they had their name, but they also had their little model number as well, and the model number would correspond to an earlier model number, but it would not correspond to the same name. So it's really confusing to try to keep up with Gibson stuff, and I think that's one of the reasons why some of their amps never caught on, even the ones that were good amps. They get kind of a reputation for being crappy, and that's because, they pretty much had at least one example of a crappy amp in just about every name you can think of. So, some of the Explorers, like these later ones, this is not going to be a great amp, really stock. Once we get it fully serviced, it's probably going to be a great amp, but stock, there's usually a lot to be desired. The reverb is really noisy on these, and as you will see when we get in here, there are leads pretty much going every which direction. it's a big spaghetti mess on the inside, and I'll show you what I mean here momentarily. But you can see here we have a 1.5 amp fuse. We have a serial number there on the chassis. If anyone's counting, we have a speaker jack, which is kind of nice because at least you can run an external speaker cabinet if you want to on these later Gibsons, which is a nice addition. We also have an external speaker jack here, so if you want to run both in conjunction with one another, you can. You can also unplug the foot switch, although I don't know why you would ever want to do that, because it has a proprietary plug on it that you really can't exchange for anything else. But yeah, let's see. Let's check out the cord here. We still have the 2-prong cord on this one, and we're going to change that for 3-prong and just do general service on this. So let's go ahead and pull the chassis, get it up on the bench, and see what kind of condition it's in. Actually, we may, before we pull the chassis, we may see what it's doing or not doing. And also, while we're back here looking, I like to go ahead and look at the fuses and see if they're correct. And this one is indeed a 1.5 amp fuse, so that's exactly what is supposed to be there. You just don't want a situation where, you know, somebody sends you an amp and it has like a 10 amp fuse in it or something. And all right, here we are with this thing up on the bench, and we're about to fire it up, plugged into the Variac. Let's go ahead and get a little bit of juice to it. All right, there we are, about halfway up. I usually like to get it about halfway up and stop and kind of pause and assess. And we're at 0.14 amps of draw, 9 watts or thereabouts. So I don't see any reason for alarm as far as the power is concerned. Starting to get some noise, and you can hear it's just, well, the tremolo seems to work. Unfortunately, that's a lot of hum that's usually associated with bad capacitors. Just out of curiosity, I kind of want to... That whoa, 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 that's the tremolo working. Kill that. There's the reverb on. So the reverb is going to be noisy. For sure. That's an output tube. That was from wiggling an output tube. Okay. Very interesting. Wow. Alright, that's just unbearable. Okay, so we know we have some issues. I don't know if they're going to be tube related or what, but we definitely have some issues to deal with here. Let's go ahead and pull the chassis and see what we're looking at. Here's the back door removed, and you can see what I mean about this being a chipboard material. Okay, here are the tubes in the back, and one thing I did notice when I was kind of feeling around back here with this thing on is when I wiggled this tube right here, a lot of the noise went away, at least momentarily, or it was greatly reduced, and that's one of the 6 BQ5 output tubes. And listen to this. You hear that little bit of rattle? This one especially sounds really trashy. And this one actually does as well, so we're probably going to need some new output tubes, I almost guarantee it. One thing I really like about these Gibsons as opposed to like Fenders is that those nuts right there that secure the chassis mount screws, those actually stay with the chassis, so you don't have to even reach in here to grab the nut or any of that kind of stuff. You can just unscrew it from the top, and the nut stays put. It doesn't fall out or anything like that. It stays right with the chassis. So that's really nice and handy. Alright, here we are inside the amplifier. We see the power transformer over here on this side. Here are the capacitors that we're going to end up replacing. These are the power caps, and these are going to be most certainly bad. We have a couple of 20 microfarads here, and couple more 20s right here on this one, maybe a third one in this one as well. No, we only have two, so two 20s here and two 20s here. And these, let's see what the date code is. These are definitely original to this amp. 1966, first week of 1966 on the date code. 10th week on this one. We have 1966 date code here, 4th week. So this is a 1966 amp, not a 67. You could see here that, I mean, just look at the lead dress of this thing. Just it's a real mess, to be honest. A lot to be desired on the lead dress on these things. I mean, for one, look at the 6-volt filament windings. None of them are wound. See, that's a 6-volt filament there. None of these are wound at all. So, I mean, this could all be rebuilt. One thing I do appreciate is they kind of color code these leads. So that's nice, but this thing has issues. From the factory, these things had issues. That resistor right there, that'll be one of the main dropping resistors. Probably the first dropping resistor between the reservoir node and the second node in the power supply, and that thing is pretty crispy, so that's going to need to be replaced. That next one down is probably drifted in value as well, and while we have that bigger one off, we might as well go ahead and replace it. So we'll probably end up doing that. The rectifier diodes here, these are notorious for going out on these Gibsons, so we might go ahead and replace those as well while we're in here with some higher value ones. We have a little capacitor here, and these are fairly notorious for being leaky. This resistor is probably okay. As a matter of fact, actually that might be the first. No, that's that looks like it's going to be a bias. That's bias for the output right there. But for sure, we are going to have to replace all of the electrolytic caps in this thing, including the big power electrolytics. And these over here, these are a different type than what you typically see in these. You mostly see this type here. I think these are Sprague, but you mostly see those in Gibsons of this era. You can see they've got these orange drop capacitors in here, and these usually hold up fairly well. I don't anticipate any of these being bad, but we can check them. We have the death capacitor over here, and you guys have been asking of several of you, especially some of you newcomers who have subscribed to the channel of late. You know, you'll notice I don't talk about in depth about a lot of things. That's because my older videos, you know, I tended to do more of that, and as we've kind of progressed, I've stopped doing that on the assumption that everybody's kind of following me, and I realize that not everybody has been following me all this time. So but you know, I've had some people asking me about the death capacitor and what it is and why you clip it out and all this. Well, to make a long story short, what it's there for is to try to eliminate some of the line noise. And what can happen on these is if they short, you basically will have your hot shorted directly to your chassis. Which, if you're holding on to your guitar at the time and your guitar is grounded to the same chassis reference, and if that shorts, then you're basically holding on to the 120 volt main. So you don't want that. So removing these is usually something that you do whenever you're installing a 3-prong power cord in an amplifier anyway, and that's what we're going to do here. So that's no longer needed on a 3-prong cord. These have several transformers in them, and that's one thing that they did not skimp on, was transformers. We have power transformer here. We have this transformer, which I think this is a choke. I think that's a filter choke. Let's see, where's it going? It's going to there. So yeah, that's in line. That's a filter choke right there. So that will actually be the first. It'll serve as a dropping resistor essentially also. So we have a power transformer, a choke, and on the other side of the chassis we have over here 1, 2, 3 more transformers. One of these will be for the reverb. That's this one right here. One of them will be for phase inversion, and I think it's this one. And then we'll have an output as well. So yeah, I mean, you know, these have a lot of good bones in them if you want to strip everything out, and if you really wanted to clean up the wiring mess and straighten things out, you can really make one of these into a great amplifier. All the bones are here for it to be one. You just got to come in here and do the work. So that's what we're intending on doing here. We're at least going to make this thing, I'm not sure, I'll have to go back to my correspondence and see exactly what the customer wanted me to do to this. If he wanted me to just repair it, then we're just going to repair it, replace and do just a general service. If he wants me to do the works, that is, make this thing the best it can be, then that's what we'll do. So let's look back at my correspondence and see what the customer wanted. Okay, we're back with this Gibson amplifier. The first thing we're going to do is go ahead and cut out all of these old capacitors in here and replace those. We know we have to replace the electrolytic capacitors, all of the little ones too, so we'll go ahead and do that as well, and then we'll come back and see where that has gotten us. You may notice some differences in the sound and lighting quality from this point on in my videos. I have upgraded my lighting scheme. I've also upgraded, hopefully, my sound over the desk here, so I think that's going to yield some better results as far as video quality going forward. So let me know what you think about that, if it's working for you. If not, I'd like to hear about it as well. But I'm going to start by removing these old capacitors. We're going to put in some terminal strips here in this middle area to put our new capacitors on. First things first though, let's get rid of the old ones. A lot of times these brackets will just break right off, and sometimes it takes a little more coaxing. This one might take more coaxing. Alright, there's one down. See, that one came off a lot easier. The other thing I immediately know I'm going to need to do is remove that depth capacitor. I can go ahead and cut that out of there. We'll also go ahead and change the power cord while we're here. Remove the tubes as well. Those power tubes are going to need to be replaced. Like I said, they just sound trashy even when you tap on them. That's not a 100% foolproof way to check tubes necessarily, but that usually is indicative, and these things are old, and with the other symptoms the amp is displaying, I would say those are probably bad. We have two 6EU7s in the first two sockets here, and we have a 12AU7 in this third socket. Instead of a tube, we have a transformer phase inverter. So there's no gain on that stage, it just inverts phase. We have the 12AU7, I believe, is in the reverb circuit, if I'm not mistaken. This cord is like something you'd see on a vacuum cleaner. It's got really thick leads on it. It's actually a decent cord. It might be usable for something else. I save these cords and recycle them into other projects when they're not cracked. Also, while I have the chassis turned upside down like this, I'm probably going to go ahead and drill these holes out, because we're going to need to put some screws in and get some terminal strips in here for holding the new capacitors. There we go. That Christmas tree bit actually worked very well on that application for taking rivets out. I think I'll do that again in the future. That was a pretty seamless way of doing it. Just basically shaved off that side of the rivet. Cool. I like to sweep up metal shavings as I go, because if you don't, they end up on the floor and then they end up in your foot later. I'm curious about these old capacitors. Let's test these out. According to this, the first capacitor tests at, what is that, 3,500 nanofarads. So that's wrong. At 31% loss. Wow. That's really lossy. Let's check the other one in this multi-section. 34% loss. 11 microfarad. Yeah, that's, both of those capacitors are bad. Let's check this one. Those were the 450 volt ones. These are the ones slightly further down the stream in the amplifier that are 325 volts. 14 microfarad, again lossy as hell. Well, this one's the lossiest of them all. 7,300 nanofarad, so about, what is that, 7 microfarad? So yeah, all of these capacitors were bad for sure. Okay, well, I dug around in my parts drawer looking for some terminals upon which we can mount the new capacitors, and this is all I have. I've got one that has the ground at the end. I've got another one with the ground in the middle. I really needed two of the ones with the ground in the middle so I could get these straight in here. It would have been a nicer way to go, really. So let me think about, yeah, see, I can't, I'm not going to do this. So I'll have to order some more of these before we can really continue with this. That's a bummer, but sometimes that does happen. Okay, well, I have the power cord wired in, and I have rewired most of the power rail. So I replaced those two resistors right there, replaced the diodes. These are 3 amp diodes, so they'll stand up a lot better than the ones that were in here. You can see here are the old resistors that were in there, especially that one. You can see how crispy that one is, and this one was a little bit crispy too. Probably a little bit underrated actually. So I've gone ahead and replaced both of those with some 2-watt metal films, and I think that's going to be a lot better in the long run. We have one of our strips in here waiting for the capacitors, and we have the other hole here waiting for the other strip to arrive. I have to order that, so we're on pause with this thing for the moment. So we'll wait a little bit, wait for that order to come in with those new terminal strips, and then we'll get right back at it. Okay, we've gotten our new parts order in, and as you can see, we've got our capacitors for the power installed. Gone ahead and silicone those together just so they don't move around on us. Also replaced, once again, replaced those 2 resistors and the 2 diodes in the power section. Replaced the power cord as well, and we're probably most of the way there. We'll give it a quick test to see where we are on this thing. Alright, let's begin firing this thing up on the Variac now. Okay, so everything looks pretty rock solid, pretty stable. I think what I want to do now is probably check the reverb and the tremolo. We can't do that really without the foot switch and the reverb tank hooked up, so we'll get those hooked up and check those. I spoke with the customer, and he says he wants me to go ahead and do the works, which means I'm going to get in here and rewire the filaments. Alright, we're back on the bench with this thing. Okay, here are the things that we are going to do. We can see once again the filaments on this. None of them are twisted. You see the white and black wires right there leading to those sockets. They need to be twisted and pushed back into the corner of the chassis, really. Also, this white wire that's coming over here, that's grounded right down in there at that point, right there. This white wire really shouldn't be grounded at the same place where everything else is eventually grounded through this switch, because everything is really getting grounded here where all the preamp stuff is getting grounded together. So I don't like grounding anything that's, you know, AC to the same spot as the preamp. So we're going to fix that. So first I want to come in here and just desolder all of these leads, I believe. Yeah, I've said before, one of the things I don't like is pulling boards and amplifiers. This is the other thing. Wiring filaments. Or in this case, undoing the wires and then wiring them back. No fun. No fun at all. Lots of other things I'd rather do other than this. Alright, so that's all the filament wires gone. Well, no, I got one more. I got this one. Okay, so I have a length of wire twisted here just for demonstration purposes. But here's what I could do. There's a couple different ways I could do this. I could, for instance, come off of this tube and then come up above it and then over and down to the next tube, and then repeat the process for this one and then for this one and this one like that. Or you can come kind of back here like this and go all the way back into the corner and then come down to this tube like this, and then do it again, come back up and then down and then up and then down, and you'll kind of have this thing going this direction. And there's nothing back here and it's pretty good and shielded. My only concern is that it's actually a further distance. I'm not quite sure yet. Either way is going to be really superior to where it was, and it's probably not going to matter either way. The main thing is that we're getting them twisted and we're getting them away from all the other wires. No matter which way we go, if we go up or if we go over, they're still going to be away from the wires. But I think they're actually going to be further away if we come up, because at least for this one 12AU, we're going to have to cross some wires to get to this point, and it would probably be better to come down to it. So I think that's what we're going to do. I think. I don't know yet. We'll see. I'm still of two minds about it, but you can see what I'm getting at. Alright, I've decided to go back in the corner of the chassis with these. So there's one down, and let's see, 1, 2, 3 more to go. Okay, let's talk a little bit about what we have going here now. This will give us a little bit of an opportunity to talk about virtual center taps. This amplifier, again, was inherently a bit on the noisy side. This does not have a center tap for the 6-volt winding. And I'll show you the schematic and what I mean here about not having a center tap. Okay, here's a schematic for the GA15RVT. You can see over here on this side, this is the primary. We have the power coming in. Here's the fuse and all that stuff over here. Here is the secondary over here on this side. Here's the main secondary where the rectifier goes and all the feeds all of the plates. Here's the heater winding. So this is 6.3 volts in this amplifier, the heater winding, and there's no center tap. Some heater windings have a center tap on the transformer, not this amplifier. And a lot of less expensive amplifiers do not have a center tap for the heaters. And what they've done here is they've just connected one side here to ground. So they're getting their ground reference from one side right here. Now what a lot of people do, and what I've done in this amplifier, is I've added a 100 ohm resistor on this side to ground and a 100 ohm resistor on this side to ground. And then I've done one better. Instead of going directly to ground, what I've done is I've tied that to an elevated point in the amplifier, and the easiest point that you can find in most amps that's elevated from ground, that is separated from ground by a resistor, is right here on the cathodes of the output tubes. Right here you're going to get a few volts above ground, and what that's going to do is that's going to just keep you from introducing a bunch of the noise, and that's going to do what's called elevating the heaters from ground with a virtual center tap, and that's what we've done here. And actually that's quieted down this amp a lot. The amp is actually on right now. It's on, and it's on 0, but even if I turn it all the way up, and with all of these lights on overhead, some of them being fluorescent, these are fluorescents, and I've got 2 of those. I've got my cell phone right underneath it, which is making noise, but if I ground my hand to this and shield this, it's virtually silent, even cranked to 10 with everything up. Well, looking at these input jacks, I found something interesting. Check this out. Look at this middle jack right here. Look at that. The whole sandwich is just coming loose. Look at it. Look at it. It's not the jack is not. It's not loose. It's tightened down. It's just the actual sandwich is loose, and it's causing noise too. So we'll have to replace that jack. What I'm going to do here is just get rid of some stuff. I'm just going to get rid of this completely. Wow, the thing just looks like, did it lose a, I think it lost a hole. Wow. That's the innermost lamination there, see? There's nothing left of the ground. That was the ground. I'll be damned. I don't know that I've ever seen that before. I think what happened was this inner sleeve in here, you can see it's supposed to bend over and around. You can see the bits that are left there, and it's supposed to secure this piece, but a few of the little bits have broken off. Well, here's the deal on these inputs. These are 3 inputs on an amplifier that no one will ever use 3 inputs on. There's really no sense in having 3 inputs. I don't get it. I mean, back in the day, maybe you would have a couple of other instruments or a couple buddies plug into the same amp, but you've got no individual control over your levels except for on your instrument itself. So, I guess you could do that if you wanted to, but it's nobody does that. There's no reason to have 3 identical inputs here. So what I might do is use these holes for something else, and we might do a couple little interesting modifications on this thing, and just I mean, because we're gonna have to replace one of these anyway, and there's really no sense at all that I can see in replacing an input jack when it's never going to be used. I mean, why not put something here that would actually be used, like a gain control, for instance. Let me think about this. This is something I'm definitely contemplating doing here. So I might eliminate not just the one control that was broken, but I mean the one jack that was broken, but I might eliminate the other jack as well and just have the one jack. Because the other thing that this is doing is adding noise. Because you've got another, basically another antenna coming off of the same point, and that's all it is. It's just an antenna hanging up in the air. And if this, you know, was dirty and this contact was dirty right here, this whole thing would just be a big antenna making noise, which is what we had a little bit ago. So yeah, I think what I'm going to do is clip this out and probably do a couple modifications and use these holes for those modifications. Maybe do something like a deep switch or a bright switch or something, who knows. But the other thing that we've noticed here is that the schematics for Gibsons are just completely useless for the most part. The schematic calls for 68K into the grid of the first tube directly, but that's not what we see. We see a 68K, but it goes through that capacitor right there over to this point, and it follows that green wire down there over to the tube. And we also have a what is that? That's supposed to be a 470 right there. Is that what that is? Yeah, we do have it. We do at least have that correct. But I'm going to change some of this stuff. I'm going to go through this amp basically, and I'm going to just make this thing. I'm going to make this thing scream. That's what I'm going to make it do. Or give it the option of screaming. If you don't want it to scream, you can turn it down. But if you want it to be there, it'll be there. And the way I see it is, why the hell not? I mean, these are pretty much a dog's breakfast anyway. I mean, look at this thing. It's like paint by numbers. They just gave somebody a little board with some numbers in a factory and just said, here, this 25 goes to 14 with this resistor, and 24 goes to blah 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 with it, you know. So somebody sat here all day and painted by numbers on this just terrible board. I mean, just the layout of it is just not good. It's not intuitive. It's not something you can just look at and say, oh, okay, I get it. You know, the whole layout's just bad. As a matter of fact, you know, this might be one of those models that would just, I mean, it's a decent amp, don't get me wrong. But the thing is, there are so many amps that are so much better that, you know, one of these would just be, and the thing is, it's got decent bones. It's got all these transformers in here, and you could use them for, you know, it's got a choke, so already it's got one thing going for it. But then they screw it up with all this lead dress, and they don't twist any of the filament wires, and you know, there's no center tap for the filaments. So all these little things add up to, you know, oh, okay, we've got a choke to try to reduce noise and, you know, smooth some ripple on the power section, but then we just get it right back because of all the other mistakes we've made. So it just doesn't make any sense. These old Gibsons are just crazy like that. None of them follow the schematic. I'm looking at a schematic right now, and it's nothing like what I'm seeing in here, and it's for the GA15RVT. The schematic I'm looking at has all kinds of things different, actually. Especially in the tone stack. It looks completely different on the tone stack almost. We've got on the first stage, the schematic shows no bypass capacitor, but there clearly we have that silver bypass capacitor, which is what, 2 microfarads, something like that. So, you know, I do think what I'm going to do here is just come through and redesign this preamp. Maybe just redesign most of this amp, period. If we look at a schematic for this Gibson, we will see here that the signal comes in, goes through one stage before it hits the tone stack and the loudness control. All of that stuff is right here. It also takes off in this direction and goes down here to another loudness control for the reverb. Then it goes through one stage, 2 stages before hitting the reverb tank. So this stage right here is not driving anything up here in the main portion of the amp when the reverb is off. It's only driving reverb signal. So what I've decided to do is take this stage and essentially move it here. So I've got input, first stage, a gain control, then I've got a second stage, which was this stage moved up, and then after that is when we're going to split off and come to here and go ahead and drive through the reverb, and we'll also go through the tone stack and proceed out of the amp. I'm going to change the tone stack. I've changed pretty much everything else for the most part. I will go through all the changes that I've done at the end, but suffice it to say, this is going to be a wildly different amp, and in my opinion, it's going to be a wildly better amp than it ever was. Alright, I know we're kind of skipping way ahead on this thing, but I wanted to go ahead and wrap it up. It's getting a bit long, so I wanted to run down the changes that were made. So first of all, here on the front panel, we can see that we have pared down the inputs to just one input. We have a switch on input 2 and a gain on input 3, and we'll get into those just a little bit further in a minute. Coming out of the input, we have a 33K input resistor to that point right there. We pick up with some shielded cable and go on to our first gain stage. We come out of that first gain stage, that would be this blue wire right here. We go to this point, and then we go through a ceramic disc capacitor, and I've selected this ceramic disc specifically for tonal reasons. We go from there on through a 100K resistor. You can't see it, but it's because it's shrink tubed, to a gain knob here. The gain knob is a 1 meg. We have right here, we have a bypass capacitor that is a bright cap. It's 680 picofarad, and it is switchable with this mini toggle switch. Coming out of this, we pick up with some more shielded cable. We can see I'm trying to use shielded cable. I'm trying to keep noise down throughout this thing, just, you know, so it doesn't build up. This thing was noisy enough as it was in the beginning, so we're trying to limit the noise and make it sound its best in the process. We come out of that second stage and come over to here, and we have a 0.047 capacitor that comes to this point. Now it comes off and splits into two different directions from here. Before it goes through the capacitor, we come off of this wire here and go on to the tone stack. Now the tone stack has been completely rewired. It is now more like a Marshall sort of tone stack. We have I've actually changed some pots as well. I've added this pot, of course. Changed this pot, which is the loudness control, to a 1 meg. Changed this pot, which was the treble control, to a 250K. Changed this pot, which is the bass control, to a 1 meg. And we also have a hidden 25K pot that is for mids. So that's kind of something that you can kind of keep as a secret. This will change the amp's kind of character from more of a Marshall-y. If you reach back behind the amp, and you have to actually reach back behind it when it's all together. And at first I drilled a hole here and wasn't thinking, because when you try to get it in the cab it won't go in, so I had to move it back a little further. So that's my fault. But that's kind of a cool little hidden thing. There was really nowhere on the front of the, front panel of the chassis to put a mid-range control, and if I put it on the back, that would put it back here close to all the 6-volt windings, and you would have to run wires again, and I just didn't want to do all that. It was better off really putting it here and just kind of making it a set it and forget it sort of control. But like I said, from this point here, it goes into two different directions. As follows: this gray wire goes through the modified tone stack, and then it goes through this 0.047 and goes off on this green wire right here to the reverb control. Now, a discussion of the reverb control. We went into this a little bit earlier. Originally this amp had one less gain stage in the preamp, and what we did was we stole, or we sort of borrowed, one gain stage that was specifically for the reverb, and we are now having it serve dual purpose. So it's still driving the reverb, but it's also driving the preamp. Whereas before it had nothing, you know, it was a complete offshoot, and it wasn't being used in the preamp. So that has pretty much revolutionized this amp so that we can crank. We have given this thing another gain stage up front, so we can crank gain, of course, and turn the loudness down, and we can drive this amp and get crunch at bedroom volumes now, which is really nice. It makes it a lot more versatile. You can also turn the gain, of course, way down. You can put it here in the 2 or 3 range, and you can crank the loudness up as much as you want and get lots and lots of headroom out of this thing. And it's just a way more versatile amp. But of course, early on we did the new power capacitors, and we changed one of them to a 47 microfarad. That's on the first node. We added a virtual center tap on the 6-volt winding, and we wound all of the 6-volt filament leads, and pushed them back in the corner. And that has quietened down this amp considerably. Now I was gonna do another modification, and that's what this is all about right here. And I experimented with it, and I was gonna make this a hum balance pot instead of just a regular virtual center tap with 200K resistors. I was gonna you know, make this pot like a 200 ohm pot. But the best I could find was a higher value, and it just didn't really work out all that great, so I ended up removing it. It would have been cool if it would have worked out, but I just didn't really have the right value on hand, and this center tap was working really well anyway, so I figured, what the hey, I'll go back to that. Of course, once again, you know, I revamped all the power stuff. All the dropping resistors are now 2-watt metal film. I've beefed up the diodes and the rectifier. Changed the bypass cap on the output to a 47 microfarad. It was a 20 before, so it'll get a little more bass on the output, especially when we've gone to that Marshall tone stack. The Marshall tone stack sort of tightens things up, but it seems to rob a little bit of the overall bass if you don't beef up that output just a bit. Changed the power cord once again. We removed the death cap, which was down here in this area. But yeah, man, this thing is now rocking and rolling. Oh yeah, I forgot to point this out. We changed this to a 1 meg grid leak resistor on this first stage as well. There are probably some other changes I'm forgetting to really make mention of here, but you can kind of see what has been done, all the work that's been put into this. And you know, I told the customer he's probably now got the baddest Gibson GA15RVT on planet Earth. So let's give this thing a listen, and I think you'll agree this is a pretty badass little amp right now. Oh, one more thing I forgot. This wire right here, this is for shielding. This is going to ground, and we changed the we actually added on the cabinet shielding all on the inside top. This is stuff I get at Harbor Freight. It's basically like it's kind of like for duct work or whatever, but it works pretty well. I mean, aluminum will shield. It's actually one of the better conductors you can get, so it does a pretty decent job at shielding. You could also get the copper shielding tape as well, and it will work too. But yeah, we're ready to put this thing back in and give it a test. Bright switch off. reverb. Notice how quiet the reverb is. When I kick it on, it doesn't add a whole lot more noise. Tiny amount, but not bad. Okay, now I'll turn the gain down just a little bit and make up for the difference with the loudness control. mid-range control and kind of what it does. Obviously, you know what a mid-range control does, but listen to how it changes the character of the amp. Okay, that's the mid-range control cranked all the way up. And if we dime out the gain, it's now the next day. I wanted to wait because I wanted to crank, and it was very late when I was doing that last little clip. So let's crank it up and see what kind of overdrive tones we can get. I'm sitting right beside this thing, so we're going to be a little more noisy. So let's just crank the whole thing. We'll crank gain, crank loudness, we'll crank the treble, and the bass. We'll just crank it all. All right? And see what happens. Okay, so that is a heavily modified 1966 Gibson GA15RVT. I hope you guys have enjoyed this video. If you have, please hit subscribe down below, hit the bell to receive all notifications, and we'll see y'all later.